Okay, so we have here an example. We have to determine the vertical deflection at midspan and the rotation at B of the given beam using the virtual work method. Okay? So from our procedure, this is our real system. Ito yung given natin. Okay, so ito yung given natin. Okay? Ito yung given natin. This is our real system. Okay? So our real system showing our real load. So meron tayong 90 kilonewton concentrated at B. Okay? So we have to determine the vertical deflection at B. O, unahin natin yung deflection. Say we have for the deflection at midspan. Okay? So for our virtual system, for our free body diagram, sabi natin, alisin natin lahat yung load ng real loading. So ito pa rin yung magiging beam natin. Ngayon, ang magiging load na natin dito sa ating virtual system for the deflection at midspan is the applied unit load kasi nga deflection yung hinahanap natin. So we have to apply a unit load at point in the direction of the desired deflection. So saan yung desired deflection natin at midspan? So we have to apply 1 unit load dito sa may midspan. Okay? So that will serve now as your load in your virtual system for deflection. Okay? So we have here now the real system and we have here now the free body diagram for virtual system. This is for the deflection. Iba din sa may rotation at B. Okay? So kindly solve first for the reactions for both real and virtual. Okay? So for our deflection virtual, kasi 1 unit load lang at midspan, this is 0.5, di ba? This is 0.5 kilonewton. Huwag niyong kalimutan. Okay? So how about for the real? Ano yung magiging reaction natin dito? Ano yung reaction natin for RB? Reaction at RB value? Value. Reaction at RB. We have
63.
We have 63 kilonewton. And for the reaction at RA, 90 minus 63, that is 27 kilonewton. Okay? So after which, we have to divide our beam into segments. Okay? Considering due to reloading, unit load, and the change in I. Okay? So kung ano yung pagkat mo dito sa real system mo, doon yun yung pagkat mo dito sa free body diagram mo on your virtual. Dapat parehas sila. Okay? And you have to look for the both free body diagram bago ka mag-cut. Okay? So pagka tinitignan mo lang kasi yung real system, tatlong cutting lang yan, di ba? AC, CD, and DB. Okay? Pero pagka tinitignan mo yung virtual system mo, magka-cut ka sa AC. Pagkadating mo dito, let's say this is E. Pagkadating mo dito sa CE, magka-cut ka din dyan. Okay? And for ED, magka-cut ka din dyan. Kahit parehas yung I niya, yung CE tsaka ED, magka-cut ka dyan because we have a change due to unit load. Meron tayong change sa CE and ED. Okay? So meron kang isang cutting dito. And then of course, yung sa may segment DB since magkaiba yung I natin. Okay? So magiging 4 na yung segment natin. Okay? So pagka nag-segment tayo, let's take A as our origin for segment C, AC. Okay? So dito, mag-segment tayo dyan, X. Mag-cut tayo dyan. Let's take A as our origin, X. Okay? Pagdating natin dito sa DE and DB, let's take B as our origin. Okay? Pwede din dito pa rin kayo sa A. Okay? Pwede din. Okay? And for DE, mag-cut tayo yung origin ko sa B. This is to minimize the equations of our moment. Okay? So parehas yung cutting ng virtual system dito sa ating real system. So magka-cut ka dyan. X. We have X. And we have X. So yan yung magiging cutting natin. Okay? So after cutting into segments, we are now ready to determine our moment equation. Okay? So for the moment equation, I have here a table for us to simplify yung magiging expressions natin mamaya. Pagka sinubstitute na natin yung moment equation natin due to reloading and moment equation due to deflection doon sa ating virtual work expressions. Okay? Para hindi lang tayo malito. Okay? So we have 4 segments. So we have AB, AC. We have segment CE. We have segment DD. And we have segment DE. Okay? In segment AC, let's take clockwise as positive. CE, let's take clockwise as positive. BD, let's take counterclockwise as positive. And DE, counterclockwise. This is your assumptions. Okay? Para alam nyo lang kung saan kayo magne-negative pagka nag-moment na kayo. Okay? So I will take this as my positive. Okay? So segment AC, ang origin ko is A. Diyan yung 0 ko. Okay? CE, ang origin ko for this cutting of segment is from A. Okay? BD sa my B and DE sa my B din yung origin ko. Okay, for the limits, tignan natin. Segment AC, ito yung segment AC natin. Ano yung limit niya? From the origin 0 to 4.5. Okay? For CE, ano yung limit natin? From 4.5 hanggang dito sa may gitna. Okay? So 4.5 plus 3, that is 7.5. So 4.5 to 7.5. Okay? BD, from 0, yun yung origin ko, BD to 4.5. Yung distances natin, yung limits natin. And for the DE, that is 4.5 to 7.5. Okay? So, yan yung mga limits natin. And for our I, huwag nating kalimutan yung I because there are changes in I in our beam. Okay? So, for segment AC, 1I lang. CE, we have 2I. BD, we have 1.5I. This is given in the problem. And for DE, we have 2I. Okay? So, let's take now our moment equation. Okay? So, moment equation. M, this denotes the moment equation for real loading. Okay? Real system. Okay? So, yung titignan natin dito is yung real system natin. Okay? For segment AC, pagka nag-segment kayo sa AC, di ba? Yan yung segment natin. Okay? Yan. Tapos, nag-moment kayo dito sa cutting plane ninyo. Ano yung magiging moment equation ninyo? Di ba? 27x. Tama? 27x, right? So, 27x, okay? Pagkapunta naman kayo sa segment CE, ito yung segment CE natin. Pagka nag-cut kayo dito, tapos moment kayo dito, moment mo yan, 27, 27x pa rin. Okay? And for the BD, pagka nag-cut tayo dito, tapos nag-moment tayo dito, ano yung magiging moment equation natin? That is 63x. Remember, counterclockwise is positive. Kaya nag-counterclockwise, kaya positive yung 63x. Okay? For the segment DE. Okay? So, positive 63x minus, meron tayong imo-moment na 90. Okay? So, 90x minus 4.5. Okay? So, we can simplify our equation here to be, ilan ito? negative 27x plus 405. Okay? Sinimplify ko lang yan. Okay, so this will be now our moment equation due to our real system. Okay? So we are finding the deflection at mean span, so we have to take the moment equation due to our virtual system per segment. Okay? So mx, you have to look at our free body diagram here sa may deflection at mid-span. Okay? For the AC, ano yung magiging equation natin dito? Ano yung magiging equation natin? Pagka nag-cut tayo dito, ano yung magiging equation natin? This is, ilan ito? Now, anyone? Ano yung magiging moment equation natin dito? Pagka nag-cut tayo dito sa AC, tapos nag-moment tayo dito sa cutting plane natin.
(0.5x, ma'am).
So we have 0.5x positive. Okay, how about for the segment CE? Ito yung cutting plane natin sa segment CE. Tapos nag-moment tayo dito. Anong magiging moment equation natin?
Positive 0.5.
Okay, 0.5. Okay, for BD. We have here BD. Ito yung cutting plane natin. We have 0.5x. And the same with segment DE, we have 0.5x. Okay? So we have now our moment equations. Okay? So now ready to apply our virtual expression. Okay? So deflection is equal to this integral of m, that is the moment for the real, and mx for the virtual of deflection. Okay? So substitute lang natin yung values natin. We have, start natin sa segment A. Limit natin 0 to 4.5. Okay? Yung m natin, that is 27x. Okay? mx 0.5x dx over ei. Plus, yung susunod na segment, we have 4.5, 7.5, that is 27x, 0.5x, dx over e2i. Okay, so huwag kalimutan, 2i tayo sa segment CE. And for segment BD plus, we have 0, 4.5. We have 63x multiplied by 0.5x times dx over e times 1.5i. Okay? And lastly, we have plus. So we have plus. Yung last, we have limit of 4.5 to 7.5. We have negative 27x plus 405. So kindly calculate this times 0.5 of x dx over e2i. Okay? So yan na yung expressions natin. So, ano na yung magiging value natin? Okay, so for our deflection, that is equal to, Okay? Yung first expression, we have 6.561 over 16 EI plus we have 907 over 16 EI. Kindly check. Plus 63 0.5, that is 5103 over 8 EI plus the fourth term, that is 17253 over 16 EI. Okay? So yan. And solving for our deflection, paki-calculate niya ito, paki-solve ito. Ilan yung value natin? We have, ilan ito?
$2,870.44, ma'am.
2,870.34 over EI. Okay?
44, ma'am.
44. Okay? So did you get the same answer?
Yes, ma'am.
Okay. So this will be now our deflection at midspan. Okay? So this will be now our deflection at midspan. So if you have the value for EI, you have to substitute EI. Okay? And before solving for the deflection, you have to make sure that your unit in EI is the same sa unit dito sa taas for you to cancel units. Okay? Dapat parehas yung units. Okay? Pagka meron kayong value ng EI. Okay? So, our deflection at midspan is equal to 2870.44 over EI. So, positive, yung sagot natin, positive means our assumption is valid and the deflection is downward. Remember, dun sa virtual natin, downward yung assume natin na direction, positive yung lumabas. In short, our assumption is valid. Pagka negative yung lumabas, mali yung ating pagkakalagay ng assumption dito, dapat pataas yung deflection natin. Okay? So that's for the deflection. And for the rotation, so we have to determine the rotation at B of the given beam. Okay? So we have to determine the rotation at B. Okay? So the same for the real system. The same yung real system natin. We have 90 kilonewton. So the same pa rin yung ating reaction. Okay? So we have 27 here. We have 63 in here. Okay? So for the virtual system, for the slope. Okay? Slope at B. Okay, so for the free body diagram of our virtual system, for the rotation at B, we have to apply a unit couple at B. So, saan ba yung B? Ito. So, mag-apply tayo ng 1 unit couple. Okay? Okay? So, this is my assumption, counterclockwise. Pagka nag-positive yung lumabas, correct yung assumption ko. Okay? Pag nag-negative, dapat counterclockwise itong couple natin dito. Okay? So for the real system, we have for the virtual system. So for the virtual system, wala tayong real load. The only load applied is the unit couple if we're looking for the rotation. Okay? Pagka tinitignan natin yung yung real system and yung virtual system, ilan yung magiging cutting plane natin dyan? Ilan yung magiging cutting segment natin? We have 3, di ba? A, C, CD, and DB. Parehas dito sa slope. AC, CD, and DB. Kasi sa CD, wala naman tayong changes ng load dito. Wala din tayong changes ng I. Even dito, wala tayong changes ng real unit. Okay? So, tatlo yung magiging cutting plane natin. So, let's take A as our origin, yung pangalawang plotting natin. Okay, let's take again A as our origin. And for the DB, let's take B as our origin. Okay. Again, yung origin ninyo, it's up to you. Kung gusto nyo ng mahabang equation for moment, you can have your origin at A, always. At the left. Okay? Pwede ding sa right lahat. Okay? So, it's up to you. Yung pag-determine ng origin for the segment as your 0. Okay? Dito lang kasi, ang i-note ko lang kasi dito, para ma-shorten yung solution ninyo, you have to consider taking your origin wherein your moment equation will be minimized, or yung mas konti yung moment equation, doon kayo mag-take ng origin. Okay? So pagka ito yung cutting segment natin for our real system, ganon din sa ating virtual. Parehas dapat yung cutting segment natin. Okay? So ganyan pa rin yung cutting segment natin. So we have 3. Okay? So we have segment AC. Let's take clockwise as positive. Segment CD, let's take clockwise as positive. And segment BD, let's take counterclockwise as positive. Okay? So, origin natin dito is from A, yun yung 0 natin, A, and for BD at B. Okay? For the limits, for segment AC, that is 0 to 4.5. Segment CD, that is 4.5 to 10.5. Okay, tama. And for BD, we have 0 to 4.5. Okay? And for your I, we have I, 2I, and 1.5I. For the moment equation. Okay? So if we take our segment here, pagka nag-segment tayo dito, yan, nag-cut tayo, tapos ito lang. Ito yung X natin. Ano yung magiging moment equation natin? Clockwise, positive daw tayo sa segment AC. That is 27x. Okay? And if we take our segment here at the CD, okay, we have moment of 27x. Okay? And for DB, if we take our segment here, that is positive 63x. Okay? And for our M alpha, this is M alpha. This alpha denotes, subscript denotes for the slope. Okay? For A, tignan natin dito. Okay? Before we take our moment here, we have to solve first our reaction. Nakalimutan natin yung reaction. Okay? So kindly solve for the reaction of our virtual system for the slope. Reaction pala muna. Reaction, ano yung reaction natin sa A? Okay, so ano yung reaction natin sa A in our virtual for the slope? Reaction sa A and B. Okay? Reaction sa B, pataas, 1/15. Kindly check. And yung reaction natin sa A, we have 1/15. Okay? So if we take our moment here at segment AC, clockwise positive, our reaction will have a counterclockwise. Kaya, negative 1/15x yung magiging moment equation natin in our virtual due to slope, for slope. Okay? And for CD, the same, that is negative 1/15x. Okay? And for the DB, segment DB, okay, we have 1/15x minus 1, di ba? 1/15x counterclockwise kasi yun yung inassume natin, counterclockwise positive for segment BD. 1/15x plus minus 1 kasi clockwise yung 1 natin dito. Minus 1. Okay? So that will be our equation in our real and virtual system for our slope. Okay? So we can now apply our virtual work expression kasi meron na tayong moment equations. Okay? So to solve for the slope, okay, so for the slope at B, that is the integral of m alpha dx over EI. Okay, so you just have to copy the equations, di ba? So that is equal to, limits natin, 0.5, 27x times negative 1/15x. Okay, dx over EI. Plus, yung next equation natin, segment CD, that is 4.5 to 10.5. That is 27x, negative 1/15x times dx over E2I. And lastly, segments BD, that is 0 to 4.5, 63x, 1/15x minus 1, dx over E times 1.5i. Okay? So yan. Kopyahin lang natin yung nasa table natin. Okay? So kindly solve for our rotation at B. Rotation at B is equal to, so yung first term natin, ito, yung first term natin, that is equal to negative 2187 over 40 EI. Okay? Our second term, ito, yung second term natin, that is equal to negative 6399 over 20 EI. Okay, kindly check. Minus yung third term natin, ito, this is equal to 1701 over 5 EI. Okay? So, wag niyong kalimutang i-divide yung value ng I natin over 2 over 1.5. Okay? So, value of our rotation. Ano yung value natin ng rotation? This is equal to negative
714.825.
So we have 714.825 over EI. This is in kilonewton meter square. Okay? So this will be now our rotation slope at B. Okay? So negative means our assumption na counterclockwise is wrong. Diba? Nag-assume tayo na clockwise yung ating one unit couple. So lumabas negative. So our rotation should be counterclockwise. Yan yung magiging direction natin.